Hey, welcome to the shop. We're back again in my magical studio, aka my driveway. If you hear a little wind blowing across the mic, it's because we have a windy day on this Saturday afternoon. I've been waiting for a little bit of sunshine to light me up a little bit. So today we are going into electrical diagnosis, and we are basically going to be diagnosing sensors using the JAL test and a 3-wire troubleshooting. So what we went ahead and did is we started out with number one. We hooked up the JAL test to the truck, keyed on the truck, started the JAL test, and a code had popped up. Now our teacher had bugged the truck, this particular truck, so that we could find what sensor was being bugged. So when we did the JAL test, the sensor came up as a boost pressure sensor. So one of the great things about having the JAL test, this particular computer, when we go in and that pops up, you can go right to where the code has popped up. You can select and it will show you pictures of the particular sensor. It'll show you a roundabout location of where the sensor is located on that particular engine, for that particular style engine. And this particular engine, we're using the 98 Peterbilt. It's the car carrier truck. And so that's the great thing about this JAL test. It's almost a guide for dummies. You know, it really does most of the legwork for you. So now we're going to continue on. This test is very simple. There's pretty much a really nice flow to it. A lot of people overcomplicate this test in basically troubleshooting what this particular thing is. What you want to do is you want to compartmentalize when you're doing any kind of troubleshooting. If you start out to troubleshoot, and you'll be overwhelmed with all the things that you will have to go through to check. So you want to start small. So here is one way to start small, and these are the steps. So step one, as we already started, we hooked up the JAL test, we ran it, we got a code. The pressure boost sensor has popped up. It's a 3-wire pressure sensor, and we went ahead and found out where the pressure sensor was located. The next step, we're going to disconnect the sensor right next to the sensor. So once we've disconnected, that gives us 3 little terminals, 3 posts to do our tests off of. Now the first thing we're going to do after disconnecting the sensor is we're going to redo the JAL test. We're going to refresh it, and we're going to see what that shows. Now this JAL test, when we ran it, it showed as short high, which means that there was an open. I know it's a short high, and you're like, how is that open? Well, this particular truck is a pull-down switch truck, which means that all the switches will be on the negative leg of this truck, basically on the common side. If it was on the positive side, that would be a pull-up switch. But this particular truck runs pull-down switch, so all opens will show as short high. If there was just a regular short and we were troubleshooting a short, it would show as short low. But this particular sensor shows as short high, so we are looking for an open. So now that we've taken the plug apart, we know that it's short low. We refresh, it's still saying, or sorry, it was short high, and we're still saying short high. We're going to go ahead and eliminate 2/3 of our check right here. We are going to do a drop across the common and the positive. So we're going to do across the A and B post, and that is going to read at 5. It should read at 5 volts. Now if it reads at 5 volts, that means you are getting power to the sensor, and the sensor is properly grounded through the common wire. The JAL test, again, also one of the great things, it'll tell you how many volts that particular sensor should be at, and there is a plus or minus above what it'll say, and manufacturer spec will give you that, what to look for. So now that you've done that 5-volt check, right there you eliminated 2 of the 3 wires to check. Now we're going to the 3rd wire. So common is good, your power is good. Now we're going to the signal wire. So we're going to the signal wire. we're going to do a jump across the signal wire. We are going to go from signal to ground, so from C to B. Now in doing that, what we're looking for is, again, we're just doing a jump across it. So we're letting the ECM read it and tell us if anything is coming back. So we went ahead, and once we hooked it up for jump, we refreshed the JAL test again. The JAL test is still showing from a short high, which means it's still showing open. So our jump didn't work. We still have a problem. So we're going to move to the next leg. We're going to go to the ECM, and we are going to unplug the harness from the ECM. So we're unplugging the harness from the ECM because what we are going to do is we are going to jump right here at the harness. Now before we jump at the harness, we have to figure out what pins do we jump at, because there are a lot of wires coming into that plug. So we're going to go ahead and we're going to reference the wiring diagram that is provided in the JAL test. The great thing about that, it highlights where the sensor is in the wiring diagram, and right there we can check and follow from B and C and follow to which pins, and the pins are numbered, and it lists pin 23 and pin 30. So we're going to go ahead and go back to the ECM. We're going to check the plug, find out where pin 23 and pin 30 is, and the little secret, I like to use a kind of a white marker. So it's like a chalk marker. So when I'm working on trucks, if I need to mark anything, for alignment or location or anything, I can use that little white marker. So I'm going to white marker over the holes so I know which holes, and I can count out the pins and find which pins that I need to do the jump across. So I'm going to go ahead and jump across the pins once I find them. I'm going to again refresh the JAL. Now JAL is going to show me short low. So short low means that it's just a short. Short high was open, short low means an actual short. So it's basically taking the shortest path. So you got electricity taking the shortest path, going right back to this or right back through the common. So since that is showing short low and it's a short, that means our open is basically in the harness. So our next thing to do is to verify that it's in the harness. So we're going to take our multimeter, we are going to set it on ohms, and we are going to do a continuity test. So we're going to hook up each end of the signal wire. So you're going to go back and find the hole for the signal wire for C, and you're going to go over to the other end and you're going to hook to the other end, and then you're going to ohm it and find the continuity. Now if it's open as it says it was, it will give you an OL reading, which means over limit. So there is basically so high a resistance that it cannot read it, which an open will also be that high of a resistance. There are certain resistances in wires, and each wire is spec'd. Once you get to so much resistance, that could be from corrosion, from wicking water and things like that. If you have an open or any kind of damage to a wire, we're going to take care of that in the next video, where we're going to talk about electrical repair, wire repair, soldering, shrink tubing, and everything like that in order to fix any electrical problems you have. So that was our 3-wire troubleshooting. So we went down, compartmentalized, and unhooked the sensor and basically checked power to the sensor. Then we went and jumped at one end of the harness. Then we unplugged the harness. We jumped at the ECM. Now for the ECM, if you would have jumped it and it would have still shown short high, then that would have meant that there was a problem with the ECM, that it continued to show that after the refresh. So if that was the problem, you would have a problem with the ECM. You would have to take that ECM out, place in a test ECM, re-diagnose, make sure everything's okay, and then basically If it turns out that that ECM was bad after checking with the test ECM, you would R&R that ECM and put in a new one. So now that all that's done, we went through, we checked up to the ECM, then the last step was to check the signal wire and ohm the signal wire and show if that was open or not. So since it showed open, we know where our problem is. Now the next is going to be finding the problem and then repairing it. So join me in my next video where we will go into electrical repair.
Yo.